the laws of logs, part 2. We need to split this single log term into multiple log terms. We can see that these are all multiplied, the x squared, the y and the z cubed, they're multiplied together. So we get log x squared plus log y plus log z cubed from the multiplication rule for logs. If we want, we can move the 2 to the front using the power rule, and we can move the 3 to the front as well. So we have a single log term and we have a fraction, so we can use the division rule for logs. So x is in the numerator, so we get a positive log term, that's positive. Y cubed is in the denominator, a negative log term, y cubed, and the power of 3 there I can move to the front here using the power rule. So here we have x in the numerator, log x, positive log term, root y, another positive log term. Now root y is y to the power of a half, or we can put the half at the front. The z is in the denominator, so a negative log term, like this. And here we have again the division rule for logs. So we have in the numerator, these are not multiplied, so we have to treat these as though they are all together in brackets. Okay, so those terms are together, so we've got log base 3 a minus 4, that's the numerator taken care of. There's a single term in the denominator, so a negative log term, same base, b. Example 2, we need to solve to work out x. We have multiple log terms, so the first aim here is to combine them into a single log term, and we can take the 2 there, which is a coefficient, and move it up here as a power. So we have log 4, and the base is 10, so I'm not going to write down base 10. Log x squared is equal to 2. And now we have the same common base, we have no coefficients in front, both terms are positive, so using the multiplication rule for logs, we have log 4 x squared is equal to 2, so I've combined them into a single log term, and now my base here is 10, so if I convert this to its exponential form, 10 to the power of 2 is equal to 4x squared, so that's 100, divided by 4 is 25, so x squared is equal to 25. When you solve this equation, we have an even power, so taking roots, so if we square root on both sides, we've got x is equal to minus 5, and we also get x equals 5. Now with log equations, we should test to see if these solutions are valid. Now if I put minus 5 in here, you can't have the log of a negative number, so I need to discard this solution. This one's fine. And graphically, there's a reason why we can't have the log of a negative number. So y equals log x. X values have to be greater than 0. We have an asymptote on the y-axis, so x values have to be greater than 0. We can't have the log of 0, we can't have the log of any negative value. Only positive real numbers. So discard solution. Solve for x. So we have multiple log terms again. There are no coefficients in front, so we can use the laws of logs. If there are coefficients, we need to get rid of them using the power rule. This is a positive log term, so we're going to use the division rule for logs, and the x plus 11 goes into the numerator, and the x and the 11 are not multiplied, so they have to stay together. You can imagine if they are in brackets, they have to stay in brackets like this. Minus, so the x minus 5 goes into the denominator because we have a negative log term. Again, the x minus 5, we have to think of it as being together, as though it's in brackets, equals 2. Now we have a single log equals some constant. We can change this to its exponential form, base power, so 3 to the power of 2 is equal to whatever's left over, this fraction, and that's a linear equation. Solve to work out x. For practice, try these questions.